All right, so now we know that when a function is concave up, right, visually it looks like a U, and we know that the average rate of change is increasing, right? And if it's concave down, then it looks like an upside down U, and the average rate of change is decreasing. All right. So that's what we learned from the last example. And but now what do we do if we don't have a function to look at, right? We don't have a function to look at here. So we're just given a table of values, and we want to find out whether these functions are concave up or concave down, or they could be neither. If there is no concavity, if the average rate of change is constant, then it would be linear. So let's look at the average rates of change of these functions, and in order to determine whether these functions are concave up or concave down. All right, so I'm just going to look at the change in the function delta. I'm going to call this is function g, so I'll call it delta g over delta x. Okay, and I want to look at what's happening. So the change in g here, it looks like it went down by 6 for a change in x of 5, right? X went up by 5. All right, so over this interval from 5 to 10, from x equals 5 to x equals 10, looks like the average rate of change is a negative 6/5. Okay, so it's a little over 1.2, negative 1.2. All right, let's look at the next interval. All right, we can't really tell anything from one interval. We got to compare these intervals. All right, so this is going down by 2, and for, again, a change of 5 in x. Okay, and then if we look at the next interval, okay, it looks like it only went down by 1 this time for a change in x of 5. So we just have to ask ourselves, is the rate of change increasing or decreasing? So which is less? 6/5, negative 6/5, is that less than, well, which is, right, it looks like negative 6/5 is less than negative 2/5, which is less than negative 1/5, right? So it looks like the average rate of change is increasing, right? So the average rate of change is increasing. Right? These are increasing. So that means it's concave up, right? When the average rates of change are going up, then it's concave up. All right. Now, notice it's negative, so it's becoming less negative, but I would have to add something, right? I'd have to add something to go from negative 6/5 to negative 2/5, right? This is like, if I could write this as a decimal, and it looks like that would be like, this would be a negative 1.2, and this would be a negative 0.4, and this would be a negative 0.2. So it might be easier to see it if you write it as a decimal, and then you can see that it's becoming less negative. It's going up, right? The values are going up, so it's concave up. All right, so let's do the same thing for this function down here. All right, we're just going to look at each interval and try to determine, we're going to look at the average rate of change over each interval, and then try to determine whether it's concave up or concave down. All right, so we need to look at the average rate of change. So that's delta h over delta x. All right, let's look at this first interval here. And so the change in the output looks like it went up by 1 for a change in x of 2. Okay, so the average rate of change over that first interval is 1/2. Here it looks like it went up by 1, but now x changed by 4, it went up by 4. And here again it went up by 1, but now we have a change of 8. Okay, so we need to compare these fractions, right? just think about 1/2 versus 1/4 versus 1/8. Well, obviously an eighth is a lot smaller than a half, right? So these values are decreasing, right? These are decreasing. And so this function is concave down. Or if you prefer, you can write CC down, right? But the final answer is that it's concave down. This one is concave up. If we want to abbreviate it, we can use that CC with an up arrow. All right, I will meet you in the next video for another example.